week, but I'll get everything done today. Okay, so here's one of them. This was by far the most frequently missed problem on this assignment. So they want to know an average rate of change, right? Think of what an average rate of change is. Average rate of change is just the slope between the endpoints. That's it, right? So for example, if we want to know, can everybody see that okay? Should I make that bigger? A little bigger?
Yeah,
A little bigger. So if we want to find the average rate of change, let's say from -3 to -2. Okay, now they're talking about x values, right? So we've got to identify those points. So when x equals -3, I'm going to walk back -3 on the x-axis and find where the function is. Well, it's right there, right? When x equals -2, I'm going to walk back to x equals -2, and then look vertically to see where the function is. Well, it's right there, right? So all I've got to do is find the slope between those points, from left to right. So what am I doing? Well, I'm going to, from there to there, I am rising by 2, and I'm running by 1. So the slope is 2 over 1, which simplifies to 2. Okay, make sense? Okay, so that's, so for this one we just get 2. Let's do maybe one more. How about from -2 to +1? Okay, so from -2 to +1, when x is -2, we were right there. When x is +1, the function is clear down there, right? So I just got to calculate a slope. So I'm going to go down this time. I'm going to rise by how many? 2, 4, -6. And I'm going to run by +3. So my slope is -6 over 3, which is what?
-2.
-2. Great question.
Oh, no.
Okay. Okay. Let's do one more. What if we wanted to go from, let's say, from 1 to 2? Okay, what if I'm going to go from x equals 1 to x equals -1, sorry, to x equals +2. So at -1, I'm right there. At +2, I'm right there. What's my rise? There isn't any, is there? So going from there to there, my rise equals 0. What's my run? That doesn't matter, 3. But whatever it is, when I calculate my slope, then I get 0 divided by some number. 0 divided by any number other than 0 is what?
0.
0, yeah. And we should know that in a way by looking at it because it's horizontal. Horizontal lines have 0 slope, right? Okay, make sense? So there's that one. That was the most frequently missed one.
Test will be on HRW or Moodle?
What do you mean? This test is on HRW. The
Oh.
Moodle one we won't do until next week.
Oh.
Okay. Okay, so that was one. Let's see, what else do we have? 8. Okay, so on what intervals are the function's values positive? This wasn't too bad. I mean, it was, most people got this, but this was still one that maybe we'll just take a quick look at. Where is the function going to be positive? What do we look for on the graph? When we talk about the function, we're talking about f of x, right? And f of x is a fancy name for y, right? So we're talking about y values. So in other words, when we want to know where are the function's values positive, we're really just asking where are the y values positive? And where is that?
Anywhere above that.
Anywhere above the x-axis, yeah. So it's going to be on this interval right here, right? So it's not positive when it's on the x-axis, only when it's above, right? So it's going to start being positive when x is greater than -2, and it ends up here. So greater than -2 and less than 1, right? Does that make sense? So if we wanted to write these intervals, greater than -2 and less than 1, or it's positive over here starting at 2, right? So when x is greater than 2 and no limit, right? Okay. So in our book, a lot of times we'll include that infinity, but we don't really need to, right? X is greater than 2 is all it takes. And actually, that's all they want down here. It's just greater than 2. We don't even need to include the infinity, right? Does that make sense? X is greater than 2 is enough. Questions? Okay. Where it's decreasing would be where it's, or excuse me, where it's negative would be where it's what? Where would the function be negative? When the y values are below the x-axis, yeah. Good. Okay. All right. Then they want to know, okay, we can skip that one. Yeah, this is probably the easiest one on there, but this was missed, a little bit. What are zeros? This is really just a vocabulary question, I think. What are the zeros of a function? X-intercepts, that's it. Zeros, what does 0 mean? 0 means where y equals 0, right? Where the function equals 0, y equals 0. So those are just going to be we want the x values where y is 0. So we're going to get -1, +1, and it looks like 3. Right, so those would be our answers. Okay, questions? All right, I think that's good for that assignment. Let's pull up next one. Okay, this was better. Here was the one that was most frequently missed, though, was the first one. And I'll tell you what, I get it. That first one, I'm not even going to bother with it. I will not put that on the test. And the reason was it was just so sensitive about getting the dots in the points in exactly the right places. Not a big deal. We'll just skip through that one.
So none of those questions on the test, right?
What's that?
None
I
of-
won't put that on no, that won't be on the test. Okay, here's one that was missed enough that maybe we'll take a quick look at this one too. And this is really an easy one. I just want to make sure you understand if you know what the question's asking, this is really simple. So you got to make sure you read these carefully, right? The model A equals 0.25t plus 29 represents the median age A. Median is just middle, right? So the middle age or the average age A of females in the United States as a function of time t, where t is measured in years since 1970. You probably remember this one. So when they say something like predict the median age, well, that means we're going to try to calculate an A value, right, from our model, right? So predict the median age of females in 1988 to the nearest 10. So A is going to be the output. 1988 has to be the input to our model. That's all it's saying. But we got to make sure we read this model carefully. So if it's the number of years since 1970,
18.
it's going to be 18, right? 1988 minus 1970 would tell us how many years after 1970. So we just have to plug an 18 into our function. That's all we're doing, right? So we're literally just saying we're going to let 18, t equal 18, and we're going to plug that in right there, right? And so if we do that, it's a calculator problem.
33.5 makes 34. Maybe.
What's that?
It's 33.5.
Is the answer?
Yeah. Maybe.
Okay, so it's 33.5 to the nearest 10th. All right, fair enough. But that's all you're doing. That's just going to be a calculator question. Okay? Good. Good, good. All right. Okay, same kind of thing here. This is another one. People did pretty well on this. There's a lot of stuff to do here. People did pretty well. This is the linear regression one. How many people feel like because I don't necessarily want to go through this whole process with everybody if they don't need it. How many people feel like they could use a little refresher on linear regression?
Hey everyone.
No, raise your hand so I can get an idea. Okay, so we will do it. That's fine. Let's do this. Okay, so linear regression. So this is a graphing calculator issue. You're going to have to use a graphing calculator on this test because you are going to get one like this.
Should be 2.7.
If you want to grab a graphing calculator, get one.
Hey, Greg, you wanna sign me one?
Nope.
So if we forget how to do this by
Hey,
calling
yo,
money.
Greg Lee, boy,
Bailey,
I'll
grab
show
one.
you.
Bailey, grab one, please. Thank you.
Can you show a calculator on the side?
Maybe.
What's that?
Can you do calculator on the side?
Uh,
Side.
You know what it's like to buy a calculator?
How come I can't?
Oh,
yeah.
Just find 3 of them.
There we go.
Go stat.
On the side?
Yeah, that's.
Oh, yeah.
Yeah, I'll do it there. Yeah.
Stat, and then.
Yeah. So we're gonna go to the stat, push the stat button to get to the stat screen, hit edit, and then we just have to put the data in there, right? If you need to clear a column, you go to the top and highlight the L1 or the L2 and hit clear, not delete. And so just put this stuff in. Which one? Okay, now on this one though, before we do that, real quick, before we do that, we got to know which is going to be our X variable, our input, and which is our Y. Good. So and we can see that, right? Because we want to. It tells us that we want to be able to predict height from the length, right? So if we're predicting height, height must be the output and length is the input, right? Okay, and that's important. Okay, so we get them all in there?
Yeah.
Once I get the data in there, what do I do?
Stat calc 4.
Stat Calc 4. So I go Stat button, scoot to the Calc menu, and I choose option 4, which is linear regression. And then I just go down and hit Calculate, and that's it. Okay, so that gives me my model, right? So then that's the first thing they ask for here, is they want to know, use the graphing calculator, find linear regression. We did that. The linear regression model is H equals blank times L plus blank. Well, in our case, remember, L is like X, right? So, oh darn it. So here's our model. Y equals AX plus B. So Y is like my H, X is like my L, and so A is being multiplied by X, or L in this case, right? So I'm going to put my A value there. It's like a slope. Whoops, let me put that so it stays. Okay, so what is A rounded to 2 places? Because it wants us to round everything to 2 places. 2.75. And then plus B, which is what? 71.97.
97.
Okay, good. And then let's see, the shortest, okay, so that part's done. The shortest length of a humerus given, if we look at the values of L, is 25. The longest is what, 39?
Yeah.
So that's going to be our domain, isn't it? That's the domain of our data. So then our domain is just going to be L is greater than or equal to 25 and less than or equal to 39. Okay, so we check. Good, good, good. Okay, now the other part of this. And there's more. So now they want to know when L equals 34. So we're looking at a 34 centimeter humerus. They want us to predict the height, right? So we're just going to plug that into our function.
165.
So we get 34. What's the answer?
165.47.
165.47. Okay. So that's the answer we get. They want us to then, if you got to read this carefully, or you could miss it. We want to round to the nearest centimeter.
165.
165, because after 5 The next digit is a 4, which rounds it down, right? So we get 165. Oops. Why is it not? I broke it. I think I did.
Try turning it off from that line.
It's not 160, it's
Oh, there
really
we
not
go.
166 if you round up.
160. Say it again.
It's really not 166 if you round up the whole thing.
No, it's not, because you don't look. I know what you're thinking. You're probably. Well, I think I know what you're thinking. You're thinking this, right? You're thinking it's 165.47. So what you're thinking is the 7 pushes that up, but it doesn't. All you do is you just look back to that. You ignore that one. If I'm going to round to that place, I just look to the next digit only. If that digit is a 5 or greater, it rounds up. If it's less than 5, we round down. Okay? So it's 165. Okay, now what about the last part of this? It says because 34 is it in the domain or not?
And
It is. 34 fits between, is greater than or equal to 25 and less than or equal to 39. Would 39 be in the domain? Yes, it would. Because we're including the endpoints, right? Okay, so it is. Okay, so Greg, it is in the domain. So what's that mean? Is it an interpolation or an extrapolation? Yeah. It's interpolation because inter means inside, right? Does that make sense? And extra means outside. So it is an interpolation, and we got it. Okay? Good. Let's see here. So how are we doing there? That one, I think that we're okay on the other stuff on that one. I'm going to scoot up to the next assignment. Oh, man, the next assignment was good. No issues. 1.3.2. One problem we'll look at, number 6. Yeah, what about this one? I understand why this one would be a little bit tricky. So the parent function here is f of x equals x squared, and they're giving us g of x, right? Okay, so if this is g of x, I'll write it down a little bigger. F of x equals x squared, and g of x equals negative f of x plus 4 over 3. Okay, first thing we got to do is we got to make this thing look right. Okay, it looks a little goofy right now. We've got to figure out, well, what do we do with this? Here's where I think most people had trouble on this. What do we do with this 3 on the bottom? If I've got something like, take a simpler example. What if I've got something like x over 2? How could I write that as something times x? Not 2x. No. Dividing by 2 is the same as multiplying by 1/2, right? So I could pull that 2 out front if I write the fraction as a 1/2, right? So I could write this as 1/2 times x. That works too, doesn't it? Because if I multiply 1/2 times x, x is the same as x over 1, right? I multiply fractions straight across, and so 1 times x is x, 2 times 1 is 2, so it works, right? We can always, if I have a denominator underneath like my function, I can always pull it out front as a fraction. Okay, so it might help to write it like this then. So we get negative 1/3 times f of x plus 4. Now it's up to you to decide what's going on there, right? So I gave you that list yesterday, right? What does it mean if I substitute x plus 4 for x in my function, right? What does that mean? What am I doing? 4 units to the left, right? Everybody get that? Because that's like saying h has a value of negative 4, right? If you look at in the book, when you look at that big template, we know that if we have f of x minus h is what tells us horizontal translation, right? Sliding left to right. It's negative in this case because it's the opposite of that sign always. We're subtracting h from x. Everybody get it? So this is like saying x minus negative 4, right?
Will we be able to use this paper during the test, or like have it out?
I'll tell you what, I'll let you do. I'll let you use it, I'm gonna let you use it on this test. I'm gonna have you guys do another little test over this stuff, over the Moodle assignments like next week. So on this one, I'll let you use it, that's fine.
How many questions will be on this test?
It's really short, I think it's like 6 or 7 or 8 or something like that, it's really short. Okay, so we know what's H then? H is negative 4, right? So what's that telling us it's doing? Sliding which direction? No, to the left. H is negative, so we're gonna go left by 4. Okay, what else is going on? Let's look at the fact that this number out front, the fact that it's negative. If I multiply a function by a negative, it reflects it over what axis? All I'm doing is changing the y value, right? Because f of x is calculating the y value, so if I multiply it by a negative, I'm just taking the opposite of that y value. What is that? So that's like a is negative, reflecting over the x, right? So if a is negative, then that tells us this reflection over x-axis. There's another thing that's going on. Now, what if I multiply the function by a number that's less than 1? If I multiply by 1/3, I'm making things smaller, right? So I'm making the y values smaller. What's that doing to the function? What's it do? Compression, right? If I multiply by a big number, I'd be stretching everything out vertically. Multiplying the whole thing by a number less than 1 means I'm compressing it vertically, right? So we got 3 things happening. So that's vertical compression. And so what are our options here? It's reflection of the graph across the x-axis, check, right? A vertical compression by a factor of 1/3, right? Oops. Okay, and a translation of 4 units, we said to the left, right? Correct? Okay. Oops, I didn't do down here though, did I? So which one is that going to be then? So it's going to be, if we look at the vertex has to get slid left by 4.
Where was it originally?
It was, well, it's x squared, so it's going to be at 0, right? So it's not that one.
C.
It could be that one. Not that one. Could be that one. No, it's not that one either, is it? The only one that slid left is B. That's all we have to look at is the translation. And it's reflected too. Okay? Make sense? Okay. All right. Okay, looks like everything was good. One more question on the last assignment, 1.4.3. And then I want you to just get in a little bit of work at least. So this is number 1. Oh, okay, I tell you what, this one, yeah, let's go through this, but this one was a little weird. Did anybody have a situation where they did it right, they know they did it right, and it didn't grade it properly? You did? Okay, a couple. This one was a little strange. I'm not sure it always graded it right. So the equation A equals 1/2 times 88. We can simplify that, right? Okay, so that's our original function. That's not the inverse, right? So we start off with A equals 1/2 times 88. That's just 40 times H, right?
Yeah.
Okay, so then what's going to be the domain of our original function? Here's a good way to look at this. So we're starting with the original. What values of H could we put in for height? Because all we're doing is calculating the area of a triangle in terms of its height. Height can't be negative, right?
Right.
Okay, so height is going to be, the domain is going to be H is greater than or equal to 0, right? And less than infinity, if we want to write that. The range will be all the outputs we get from that. Well, if I put 0 in for H, I get 0 for A, right? But if I put in any other value, any positive value for H, I'm gonna get back some positive area, right? So does everybody agree that the range is gonna be Y is greater than or equal to 0 and less than infinity? Okay, if I wanna calculate the inverse function, all that means is, I'm just gonna switch around those two, which variable is I'm solving for? Which one is the output variable? In our original, H is the input, A is the output, right? So we're just gonna solve for H, that's all it means. To solve for H, what do I have to do to get the H by itself? Divide both sides by 40, everybody agree? So my inverse is just gonna be H equals A over 40, right? Okay, so what's the domain of the inverse gonna be? Well, the domain of the inverse, this should have been an A, right, not a Y. The domain of the inverse is the range of the original. Everybody agree? I don't have to do any work at all. Whatever I got for the range of my original function, that's the domain of the inverse. Okay. So it's gonna be A is greater than or equal to 0. Inverse function is, what is it? A capital, it has to be capital. Variables are case sensitive. A over 40. Yeah.
It's 1/2 40H. So it would be 20.
No, in this case, it was an 80.
Oh.
Yeah, it's different problems. Yeah, yours might have been that way. And then the last one, it wants us to graph this thing. Okay, so graphing this. This is where I think most people had an issue. Not a big deal. If I'm graphing this function, right? If I'm graphing the function H equals, same thing as saying 1/40th A, right? If I pull that 40 out front. That's just, we're gonna compare that to Y equals mx plus b. So what's my slope? Because A is like my x variable now, that's the input. H is my output in this equation, right? So 1 over 40 is my slope. And what's my y-intercept? 0, it doesn't show up, right? So it's 0. So all I've got to do then is just graph a line with a slope of 1 over 40 and a y-intercept of 0. So I could go up 1 and over 40, but that's not very convenient because it doesn't fall on the corners of the graph paper. So instead of 1 over 40, what's another fraction that would be better that's equal to 1 over 40?
2 over 80.
Like 2 over 80? I could go up 2 and over 80, right? So I could do something like that. Start there. As long as I create those 2 points, it'll extend the function out there. And that should be right, but it seems like there were some cases where maybe it didn't always. Did it do it? Yeah, I guess it did, okay. So the inverse function, h equals a over 40, gives the blank of a triangle with a base of 80 inches. So
Height,
gives the height, is the output, as a function of
area.
a, right? Because h is what we're solving for in this case. It's a function of area in square inches. Boom. Got it. Okay? Work. I don't know how much time there is, but the rest of it, get some questions answered, work a little bit.
Maybe.
How do I